Hi, in this video I'm going to show how to generate a CUDA GPU code for a YOLO version 2 convolutional neural network. This is the article that I'm going to use in this example. It's going to be listed in the description of this video along with two additional videos. One of them how to generate a C++ code for this same example, and another one describing this YOLO version 2 convolutional neural network architecture in more detail. So I'm just going to focus in this video only on GPU code generation. Okay, so to start, let's open the script, and that'll take us to the script. Okay, the first step is to load the network. It's gonna take some time. We can use analyze network to take a peek at how the network looks, but I'm not gonna go into detail for that. For more details, go to the C++ code generation YOLO version 2 video or the YOLO version 2 video. Okay, so the script that we're gonna use is this one. It's the same as the other ones. As the one in the C++ code generation video, it's just gonna load the network into a persistent variable to load it only once. And we're gonna use the detect method that's gonna take the input image, pass these threshold parameters, and we're gonna get the bounding boxes and the labels. And for MATLAB execution, this is not code generation. We have to use some set string grabbing, and the bounding boxes and the labels are fed to this insert object annotation computer vision function that is gonna put the labels in the image, and that'll give you the output image. So for code generation, we're gonna create instead of a regular configuration, we're gonna use a GPU configuration for MEX, because we want to compile the CUDA code into a MEX file to run it in MATLAB. If we could also generate an executable or a library. We can specify that in here by saying bit or exe or something like that. So we got the configuration. Still, this is based in C++, so that's the target language, and we're gonna use a deep learning configuration. In the case of the C++ video, this was Intel MKL, a math kernel library, but now we're using CUDA, so we're gonna use the CUDA-DNN library. Okay, so here we got the configuration, which we're gonna pass in here for the codegen command. We pass the name of the script, and we pass the argument information. This can be a value or a type. This is the same thing as the C++ example, so you can get more details there. Okay, so let's generate code. Okay, we're gonna get the code in the same MEX file, and the same. We're gonna have an entry point called YOLO version 2 detect. It's gonna be .cu for CUDA. And then we're gonna use these commands to get a video, which is gonna be a car running the highway, and we're gonna use the view reader to get one image at a time. We have to resize it to fit it into a network, and then once the generate code is complete, this codegen is automatically going to compile the C++ code into a MEX file that you can use within MATLAB, and we're gonna get it here. So we can invoke it like this. It's going to be the same name of the function underscore MEX, and we can just pass the input image from MATLAB and get the output image with the labels. And then we use the deployable video player to view the image. So we're going to see a video of the cars being labeled. Okay, so I'm going to run these commands in this script, and the reason is I want to time it. I'm not going to debug through it. I already did that in the C++ code generation video, so you can see a debugging through that. I'm just going to take the time to compare it. The execution of this, we use the same commands for the C++ video. It was about 30 seconds, 33 seconds the two times that I executed. So I'm going to execute it a couple of times. The first time is just to show you how it looks, and then I'm going to run it again without showing how it looks, so that it doesn't affect the execution time. Okay, so I guess we're getting something already, so we can take a peek at the code before it finishes. And here's the entry point. Okay, so you can search for the name of the method within here, and that's gonna be your entry point. And if you use preserved array dimensions in here, you can get a three-dimensional vector in here for the input image and the output image, but since we didn't specify that, we're gonna get a flat vector. So unlike the C++ code, which was a little bit more understandable, this is gonna get a lot of GPU kernels. Like gonna get different algorithms into here, and you get the activation of the deep learning network, and you should get some post-processing somewhere, like we did before. It might not be visible, and eventually you're gonna get you're gonna call the computer vision function to put the annotations into the image. It's kind of a little bit harder to understand. Another important file in here is the deep learning network, and in here if you search for predict, you're gonna see that each layer is gonna get a predict method, and if you go to a particular layer, let's say a convolution or something like that, a fuse convolution layer, let's take up this one. You can search for predict, maybe not this one, but this one, the implementation of the convolution layer. You can see that it's a little bit cryptical, and this is where should be where the library is invoked, the CUDA library. Anyway, all of that is compiled automatically in the MEX file as mentioned before, and the MEX file is going to be over here. So let's execute this script. First, I'm going to execute just to show you how it looks. It's going to take a while the first time it loads. Maybe because of the persistent variable is loading the network, but then in further runs it's way faster with because now it's using GPU. The last time that I ran C++, I mean regular CPU, and yeah, it took about even when I moved the video from the left screen to the right screen, which should have affected the execution time and also the loading, is still 17 seconds, which is about half of what it took. So I'm gonna run it now without alteration. It should be 1, 2, 3, 4, 5, 6, 7, 8 seconds, something like 8 seconds. Yeah, actually it took less than 8 seconds. Yeah, so it's way faster, like more than 3 times faster. Okay, so that's for the video. Thank you very much for watching.